Welcome back to Daily Dose of Space. When we ask about the oldest thing in the universe, the question sounds simple. We instinctively think about ancient stars, distant galaxies, or maybe even black holes that formed shortly after the Big Bang. But in cosmology, age is a complicated concept. Because the universe doesn't just contain old things, it remembers its past. And the oldest thing we can observe is not what most people expect. It isn't a star. It isn't a planet. It isn't even an object in the traditional sense. It is something far more fundamental. Age in a universe that moves. In everyday life, age is straightforward. Something forms, time passes, and it gets older. But the universe doesn't behave like everyday life. Space itself expands. Time stretches differently depending on gravity and motion. Light travels, carrying information from the past into the present. This means that when we observe something distant, we are not seeing it as it is now, but as it was when the light left it. In astronomy, distance and age are inseparable. A galaxy billions of light years away is not just time. It is young. When we look deeper into space, we are peeling back layers of cosmic history. Each layer takes us closer to the beginning, and eventually, we reach a point where no stars existed at all. The first stars and why they are not the answer. For a long time, scientists assumed the oldest things in the universe must be the first stars. These early stars, known as population 3 stars, formed from pristine hydrogen and helium, untouched by heavier elements. They were massive, short-lived, and violent, burning bright and dying quickly. But there is a problem. None of them still exist. They lived fast and died young, leaving behind black holes and enriched gas, but no direct survivors for us to observe today. The oldest stars we can still see formed later, after the universe had already been reshaped by earlier generations. So, while stars are ancient by human standards, they are not the oldest witnesses of cosmic history. They arrived after something else had already been there. Galaxies, black holes, and a surprising limit. What about galaxies? Some galaxies formed incredibly early, just a few 100 million years after the Big Bang. Observations from modern telescopes show surprisingly large and mature galaxies existing far earlier than our models once predicted. Even more puzzling are supermassive black holes, already weighing billions of times the mass of the Sun at a time when the universe should have been too young to build them. These discoveries challenge our understanding of how fast structure can form. But even these extreme objects have a beginning that comes too late. They are products of an already evolving universe. They are not the universe's first memory. To find that, we must go deeper. The last scattered light. If we continue looking back in time, galaxies fade away. Stars disappear. Eventually, we reach a period when the universe was hot, dense, and opaque. Light could not travel freely. Photons were constantly scattered by charged particles, trapped in a glowing plasma. Then, something extraordinary happened. About 380,000 years after the Big Bang, the universe cooled enough for electrons and protons to combine into neutral atoms. For the first time, light was able to move freely through space. That light was released in every direction at once, and it is still traveling today. This radiation is known as the cosmic microwave background. It surrounds us completely. No matter where we look, we see it. It is faint, uniform, and incredibly old. It is the oldest thing we can observe, not an object, but a signal. Why this light is older than everything else. The cosmic microwave background is not just old, it is foundational. Every star, galaxy, and planet formed after this light was released. All cosmic structure grew on top of the conditions it reveals. Tiny variations in this radiation map the earliest density fluctuations in the universe. These fluctuations would later collapse under gravity, forming galaxies and clusters. In a very real sense, this light is the blueprint of everything that followed. When we observe it, we are seeing the universe before complexity emerged, before stars, before planets, before chemistry. We are seeing the universe remember itself. This raises an unsettling question. Is the cosmic microwave background truly the oldest thing? In theory, there may be things that existed earlier. Gravitational waves from the very first moments of the universe could still exist, carrying information from fractions of a second after the Big Bang. But detecting them is far beyond our current capabilities. There may also be particles, fields, or structures from even earlier phases of cosmic history. But we cannot observe them directly. The cosmic microwave background marks the oldest visible boundary of reality. Beyond it, the universe becomes hidden behind a wall of opacity and time. So when we ask what the oldest thing in the universe is, the answer is not something you can point to. It is not a place. It is not an object. It is light. Light that has traveled for nearly the entire age of the universe, quietly filling space, carrying a memory of creation itself. And every time we study it, we are reminded of something humbling. The universe does not erase its past, it carries it with us.